in this video I'm going to talk about the need for having a route, or at least a default gateway, which is kind of like a route. In this scenario, we've got two PCs. We've got a PC here and a PC here. They've both been configured correctly with IP addresses and default gateways that lead to their default gateway, which for PC1 would be this Ethernet interface on router 1, R1. And for this PC, PC2, he has a default gateway of R2, which is R2's Ethernet interface, which is right here. We've got a situation where I'm not sure why this computer here has a straight through Ethernet cable because it's connecting to a switch, and this computer has a crossover cable because this computer's connected directly to the Ethernet port of the router. But anyway, everything's been configured correctly, and the problem is that the PC can ping the router here. It can ping the serial interface of the router here, but it can't ping the serial interface of the router here. So, for example, we'll do this right now. I'll click on the PC. I'll open up a command prompt. It's kind of small. Hopefully you can see it. And I'll do an IP config, and it tells me that my IP address is 34 with a default gateway of 33. So if I ping 192.168.1.33, I get a response. And so that's successful. So that just told us that this PC can ping this router. And what a ping is, it's an echo request that goes to the router, and then the router sends an echo reply back to the PC. Now, what about this other router interface? The other router interface, the serial interface right here, if I click on this router here and I say physical, and let's see here, config, and I click on serial, you can see that it has a 1.66 interface right there. So let's try to ping that. So from this PC again, I will ping, this time I will ping 1.66 and hit enter, and that is successful. So I can ping this interface right here, serial interface. So now I'll try to ping this interface here. So click on this router and click here on the serial interface there, and it's 1.65. Okay, so we'll try one more time. We'll click on this PC again. I've got the command prompt, and I'll try to ping 1.65, and you'll see that it breaks down right there. I can't ping 1.65. The request times out. So what's happening here is I can ping here, but I can't ping here. So if I can't ping here, I definitely can't ping this other PC over here. So the question is, why is that? Why can't this PC ping this router? Well, the answer is this. The PC has a gateway. So a gateway is kind of like a route. So if the PC wants to send a packet somewhere that it doesn't know about, it sends all packets to its default gateway. So it has a default route. It has a default route going this way. So the PC doesn't know how to get to this interface, but that doesn't matter because it's got a default route going this way. So it sends it to the router. So the router receives the packet. All right. So now we're the router, right? And we need to deliver this packet over to here. Well, does this router 2, does R2 know how to do that? Sure it does. If we click on the router and we click on the command line interface, and we'll get to the main prompt here, and this is the privileged exec mode, and I'll do a show run command. No, not show run. I'll do a show IP route command. You'll see that this router knows about two routes. It knows about the 32 network, which is directly connected to its Ethernet interface, and it knows about the 64 network, which is connected to its serial interface. So it has two routes that it knows about, and it knows about these routes because they're on connected interfaces. They're directly connected. So this router knows about this network right here, and it knows about this network right here. So when the packet gets to the router knows how to send it right here. So the packet actually arrives at R1 on its serial interface, right? The problem is the packet never returns. So the echo request actually gets to the destination, but when R1 tries to send it back to PC2, we look at R1's routing table, and when we look at R1's routing table, we'll see that R1 has no idea where to go. So R1 knows about the 0 network connected to its Ethernet and the 64 network connected to its serial, right? So R1 knows about this network over here, and it knows about this network over here, but when it tries to send an IP packet back to this network, or to this computer here at 192.168.34, it doesn't have that network in its routing table. So this router here has no idea where the 1.32 network is. And this router does not have a default gateway. It does not have a default route, or what's called a gateway of last resort. So the router has no default setting on where it sends packets if it doesn't know what to do with them. Unlike the PC that actually has a default gateway, it knows what to do with a packet that it doesn't know what to do with. It sends it this way to this default gateway. But this router doesn't have one of those, so it doesn't know how to send it back. So if we put in a static route to this network, the whole thing will start working. We've got to check to see what network this PC is on. This PC config is 1.33, so this PC is on the 32 network. Okay, it's on the 32 network. Let's see here. There it is. Oh, this PC is 34. He's on the 32 network. Okay, he's 34, and he's 34 and he's on the 32 network. All right, that's good. Gateway's 33. So he's on the 32 network. All right, no problem. So we go to the router. We want to put in a static route. So we go configure terminal, or conf t for short. We get to global config mode, and then we put in a static route. We put in IP space route space 192.168.1.32 space the subnet mask, which I believe is 255.255.255.224, and then a space, and then the interface that we're going to send it out of. And in this case, if we are router 1, we're going to send it out our serial 0 interface. So we'll just put that in there. So we'll say S0/0/0 and hit enter, and it's all good. And now this should start working. So now we go back to the PC and we try to ping that interface like we did before, which is 192.168.1.65, and this time we get a reply. So now the router knows how to send the packet back to us. So the router sends it back, and so now our ping is correct. So if we want to make this whole network work, all of these networks work, then we need to give router 2 a static route to reach this network over here, just like we gave router 1 a static route so it could reach this network over here. And that's it.